Lesson 8.1, we're going to talk about oxidation states. We're nearing the home stretch. Before I begin, get your reference table. Okay, an oxidation state, all it is it is a hypothetical charge of an element in a compound. Now, before you start determining how to assign oxidation states, you need to figure out a couple of rules. All elements, first of all, elements are always zero. An example of an element, sodium, elemental sodium. Oxygen, even though it's O2, this is still an element. So this oxidation state is zero, this oxidation state is zero. In fact, all of the diatomic elements, now pay attention to this because I'm going to say this and I've said it before and you're going to have to know this for the regents. All Hofbrinkels have an oxidation state of zero. What is a Hofbrinkel? I've said it before. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. They're all diatomic elements. Diatomic, you know this from the last unit. Di means two, like dimethyl, dibutyl, dipropyl, dibromo, and diatomic, two atoms. So each one of these has an oxidation state of zero. Even though there has a little number 2, each one is considered to be zero because it's not giving off a charge. Another example of elements, anything like iron, I don't know, vanadium, you could have carbon, all these. If it's an element, it's going to be a zero. Okay, that's the first rule. Now another general rule of thumb, group 1 is always oxidation state of +1. Group 2 is always an oxidation state of +2. And finally, for the third rule, oxygen, for our purposes, is always going to be -2. Now, sometimes oxygen is going to be -1, but for the high school chemistry curriculum, oxygen is -2. Just remember that. When you get to college and take college chemistry, worry about it then. It's somebody else's problem. Now, how do we determine oxidation states? Let's look at a few different examples. We're going to start easy and we're going to get a little bit more complicated. First of all, sodium chloride. First of all, sodium chloride. Sodium is in group 1. Chlorine is in group 17. If you look at sodium, its oxidation state is only +1. Now you're going to write a plus and a 1 just to indicate that it is a positive and the quantity. Now if you look at chlorine, it is either +1, -1, +1, +5, or +7. Now since the overall charge of this, there's no number up here, so the overall charge of sodium chloride is 0. So the sodium and the chlorine have to add up to 0. So that's +1, that's -1. And when you figure that out, just double check and look at the oxidation states of both of the elements and make sure that they are listed in there. Because if there would not be a -1 in chlorine, that would be incorrect. But there is a -1, so it's correct. A little bit more complicated. Let's do H2SO4. Now, hydrogen is in group 1, but it says +1 and -1. So I'm not so sure I'm going to think it's +1, but let's come back to that in a second. So oxygen is going to be -2. Now remember we talked about this when we did ionic compounds. Okay, so oxygen is -2. There's 4 of them. So oxygen is going to have a -8. Now the hydrogen and the sulfur have to balance that out. And if you look at sulfur, it could be either -2, +4, or +6. There's 1 sulfur and 2 hydrogens. So let's just, if this is +1 or -1. There's no possible way that hydrogen can be a -1 because it's going to bring this number more negative. We want to equal these out. So this is going to be +8, this is going to be -8. So if this is +1, the overall charge is going to be plus 2, which means this number here needs to be plus 6. So let's see, does sulfur have, we look on the oxidation state right there, sulfur is plus 6. Plus 1, plus 6, minus 2. These numbers down here are not the oxidation states necessarily. Only for sulfur, because there's only one element. One element, the oxidation state, is the same as the overall charge. Plus 1 times 2 is plus 2, negative 2 times 4 is negative 8. These numbers up here are the oxidation states. I'm going to try one more, and then I'm going to leave you to your own devices. We're going to try potassium permanganate, KMnO4. When you do these problems, typically, if it's a big one like this, they're going to give you something like this on the regions usually. Okay? Usually, oxygen's the only negative, and these two are going to be positive. Usually. But, not always. Oxygen, like I said before, negative 2. Potassium, plus 1. Now let's figure out our math.